Let's say we're given this function f of x equals x squared minus 8x plus 15, and we're asked to graph it. And the first thing we can do to graph is find the vertex, which, as you can see over here, the x value, they use h and k, but the x value of the vertex is negative b. My b is negative 8 over 2a, and my a, there's understood to be a 1 in front, because remember this form, this is a x squared plus bx plus c. All right, so negative and negative is a positive, so it looks like at x equals 4 is going to be my vertex, but what's the y value? Well, simply plug 4 into my function. 8 times 4 plus 15, and if you pick up a calculator, I got negative 1. So that means my vertex is hitting at the point 4, negative 1. And then it asked how to find the axis of symmetry. Well, the axis of symmetry occurs at the x value of your vertex. And then I can graph this, and typically what you like to do is find the x-intercepts. And how you find the x-intercepts, set this equal to 0 and find the factors. Because notice, if this is equal to 0, this is the y, which means you are on these x-axis. So I can factor this, I believe. X squared is just x times x. I look at 15 as 5 times 3 because 5 plus 3 will give me that 8. The middle is negative. This is positive. A negative and a negative will give me a positive 15. And then a negative 5 plus a negative 3 will give me that negative 8. And setting both of these equal to 0. And x minus 3 equals 0. I get x equals 5. And I get x equals 3. So I could graph this pretty easily. Let's see if I can draw some straight lines here. Meaning that I know that 1, 2, 3, 4 and negative 1 is going to be the bottom. And how do I know this is the bottom? Remember, if your a is greater than or equal to 1, in other words, meaning that it's positive, that it's a positive value, that this will definitely be concave up, so it'll look like both of these. I note over here that it's going to go through at 1, 2, 3, 4, 5. Okay, that's why I got these. And so if I can draw a parabola, kind of, that's what it's going to look like. And of course, that would be my axis of symmetry.